Let us look at logarithmic series. Now, if x is between -1 and 1, where -1 is excluded and 1 is included, then we have to figure out what natural log of 1 plus x is as a series. Now, why this specific domain? Primarily because if we had taken -1 also, then we would have ended up with 1 minus 1, which is 0, and natural log of 0 is undefined. Okay, so and less than or equal to 1 to make sure that we have a number between 1 and 2. 1 plus x can be written as e to the power of natural log of 1 plus x, because e and natural log cancel out. Now let y be equal to natural log of 1 plus x, which means e to the power of y is equal to 1 plus x. Quite a neat trick. Let us express y as a power series in x. So a power series is of the form a sub naught plus a1x plus a2x square plus a3x cube and so on. Here, natural log of 1 plus 0 is equal to natural log of 1, which is equal to 0. And hence, a sub naught will be equal to 0. So let y be equal to, in terms of power series, a1x plus a2x square plus a3x cube plus a4x4 plus dot dot. So here we are not writing a sub 0 because it is equal to 0. Now, since we know the expansion for e to the power of x, and here x is equal to y, we have e to the power of y is equal to 1 plus y square by 2 factorial plus y cube by 3 factorial plus y to the power of 4 by 4 factorial and so on. Now, let us approximate up to 4th power. We could as well go forward, take higher powers as well. But I think this will give us a pretty good idea. So, which means we need y square, y cube, y to the power of 4. Y we already have as per the assignment. Where is it? Y is equal to a1x, a2x square, a3x cube, so on. Y square, we square this and just take the powers up to 4 and then group the like elements. So we end up with a1 square x square plus 2a1 a2 x cube plus 2a1 a3 plus a2 square x to the power of 4 and so on. So let's remove this dot dot dot, because we have said we are going to take it up to 4th power. So y cube will give us a1 cube x cube plus 3a1 square a2 x to the power of 4. Again, we need to remove the dot dot. And y to the power of 4 is equal to a1 to the power of 4 x to the power of 4. Okay, now let's substitute these expansions into e to the power of y expansion. We get this 1 plus y by 1 factorial plus y square by 2 factorial, which is 2, plus y cube by 3 factorial, which is 6, plus y to the power of 4 by 4 factorial, which is 24. Now let's make some space. So what I'm doing is e to the power of y is equal to 1 plus x. So I write 1 plus x and this entire right hand side. Coefficient of x on the right hand side is a1, and on the left hand side it is 1. So a1 is equal to 1. We are equating the coefficients. Coefficient of x square is going to be a sub 2 equal to minus 1 by 2. So basically we have to simplify this and group the like terms. Now, coefficient of x cube is equal to a sub 3 plus a sub 1 times a sub 2 plus a sub 1 cube by 6. Since we already know a sub 1 and a sub 2, substituting it, we end up with a sub 3 equal to 1 by 3. And similarly, coefficient of x to the power of 4, that is a sub 4 is equal to minus 1 by 4. Y expansion is this. A1 we have found, A2, A3, A4 we have found. So we have natural log of 1 plus x is equal to, because y is equal to natural log of 1 plus x. In case of A1x, A1 is 1. So just x minus of the half, x square by 2 plus x cube by 3 minus x to the power of 4 by 4 and so on. Again, since we are restricting ourselves to up to 4th power only, this dot 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 is not necessary, but if required, we can keep going and taking higher powers as well. But this itself, up to 4th power itself, gives us a pattern for the terms. Now, this can be written as natural log of 1 plus x is equal to the summation or the series minus 1 to the power of n minus 1 times x to the power of n divided by n. And this is called the logarithmic series. That was logarithmic series. Now we will use this to figure out some additional series. If you found this session helpful, please do like, share, and subscribe. Questions and suggestions are always welcome. Thanks for watching. See you in the next session. That's it for now.